June 30th, 1908. Dawn breaks over the remote Siberian taiga. Suddenly, the sky just rips open. Columns of fire shoot into the air. A bluish-white light, brighter than the sun, streaks across. Then, this massive explosion. It's light, visible thousands of kilometers away, even in England.
People were thrown off their feet, windows shattered hundreds of miles away. The earth shook like cannons firing. It's almost unimaginable scale.
Especially for 1908, right? And so remote. It really sets the stage for one of the most compelling cosmic mysteries we're diving into today.
Exactly. We were talking about the Tunguska Event.
That staggering puzzle from June 30th, 1908, deep in Siberia. We pulled together a whole stack of sources, scientific papers, historical accounts, eyewitness stories.
And our mission here is to give you a shortcut, really, to understanding this unique historical impact event. What happened, the first investigations, the main theories.
And the mysteries that, honestly, still hang around it. So let's get into this cosmic riddle.
Okay, first things first, the basics. June 30th, 1908, around 7:17 a.m. local time.
And the location is key, near the Podkomenaya Tunguska River. Super remote part of Siberia, even today.
Extremely remote. But the power, undeniable. Estimates vary, as they often do, but we're generally talking 10 to 15 megatons of TNT equivalent. Some models go lower, maybe 3 to 5, others higher, up to 30.
Okay, let's put that in perspective. The first atomic bomb test, Trinity, that was about 15 kilotons, so Tunguska was potentially 1,000 times more powerful.
Right, more like the Castle Bravo hydrogen bomb test in '54, an explosion that could wipe out a huge city, just gone.
And the physical evidence on the ground was just staggering. Over 2,150 square kilometers, that's like 830 square miles of forest flattened.
Yeah, think about an area the size of Tokyo or London, just flattened trees, laid out in this huge radial pattern, pointing away from a central point.
Though the number 80 million trees, that might be a bit high, an earlier estimate.
Probably an overestimate, yeah. But the scale of devastation is still immense, and what's really weird is the trees right underneath the explosion.
Right, they weren't knocked down, they were just stripped bare, scorched, but standing.
Exactly, like giant matchsticks. While the trees further out were just blown flat outwards, you can still see some of the charred remains today.
And the effects went way beyond the trees. The shockwave itself.
Oh, yeah. Broke windows, knocked people down hundreds of miles away, and the ground shook. Seismographs picked it up as far as 1,000 kilometers away, like a 5.0 earthquake on the Richter scale.
Wow. The whole planet felt that, essentially.
In a way, yes. Airwaves were detected even further, Germany, Denmark, even Washington, D.C.
And then there were those really strange atmospheric effects afterwards. The glowing skies.
The bright nights, yeah. For several days across Europe and Asia, the night sky was so bright. Well, people took photos at midnight in Sweden and Scotland without a flash.
Ow. What was causing that?
Well, the main theory involves high-altitude ice particles. Tiny ice crystals forming way up high, maybe 80 kilometers up, because of the material and water vapor thrown up by the event, catching the sunlight.
Okay, that makes some sense, like noctilucent clouds, but on a massive scale.
Sort of, yeah. Something similar was seen with space shuttle launches later on, which kind of backs up the idea. In observatories like Mount Wilson in California, noticed the atmosphere was less transparent for months.
Dust.
Dust, yeah. Fine particles thrown way up into the stratosphere, blocking a tiny bit of sunlight. It even seems to have caused a temporary dip in the ozone layer, a global effect from this one remote blast.
It's the human stories that really bring it home, though. Like S. Semenov. He was relatively close, about 65 kilometers south.
Right, at the Vanavara trading post. He described seeing the sky split in two, this wave of fire.
He said it got so hot he felt like his shirt was on fire. Then thrown meters, this huge thump, and a noise like rocks falling or cannons.
Windows shattered. An iron lock on a barn door just snapped. Imagine experiencing that. Utter terror.
And then there's Chuchan from the Shanyagar tribe. He was sleeping in his hut.
Yeah, he recalled being shoved, hearing whistling, a strong wind, being thrown into the fire pit in his hut, trees falling everywhere.
And seeing a second sun that hurt his eyes. Followed by thunderclap after thunderclap. Just chaos.
Absolutely. And even newspapers hundreds of kilometers away reported it. The Siberian newspaper talked about peasants seeing this strangely bright, bluish-white heavenly body falling.
Looked like a pipe or cylinder. Then this giant billow of black smoke and a loud knocking, like artillery fire shaking buildings.
Exactly. Siberian Life mentioned ground tremors, two big explosions like artillery. Krasnoyarets reported a noise like wind, then a horrific thump, an earthquake, and then 50 or 60 more bangs like cannon fire. Consistent picture of awe and terror.
Okay, so you have this massive event, incredible eyewitness accounts, widespread physical effects,
Yeah.
but the big initial mystery was no crater.
Precisely. No impact crater, no obvious big chunks of meteorite. That absence was really puzzling and fueled all sorts of weird theories early on.
Which brings us to Leonid Kulik, the Russian mineralogist who led the first proper scientific expeditions.
Yes, starting around 1921, though his main expedition to the site wasn't until 1927. He was convinced it was a giant meteorite impact. He wanted to find the iron.
But when he got there, surprise, no crater. What did he find instead?
He found that central zone, about 8 kilometers wide, right under the presumed explosion point, the hypocenter. Trees there were scorched. Yeah, branches ripped off, but still standing upright.
The matchstick trees.
Matchstick trees. And all around that for miles, this vast radial pattern of felled trees. He described it like a gigantic spread-eagled butterfly. He did check out some swampy bogs, thinking they might be craters.
But they weren't.
No. He even dug into one and found an old tree stump at the bottom. Definitely not an impact crater.
So if there's no hole in the ground, what does that suggest? And how did they eventually figure out it was something from space?
Well, the lack of a crater strongly suggested the object didn't hit the ground intact. It must have exploded in the air. An airburst. The confirmation of extraterrestrial origin came later from expeditions in the 50s and 60s. They found microscopic evidence. Tiny little spheres of silicate and magnetite, minerals found in meteorites, embedded in the soil, and even in tree resin from 1908.
Ah, some microscopic fragments.
Exactly.
Yeah.
And these spheres had high levels of nickel mixed with iron, which is a classic signature of space rocks. Then they looked at peat bogs.
Why peat bogs?
Because they preserve layers over time really well. And peat samples dating back to 1908 showed weird isotopic ratios for elements like carbon and hydrogen, plus high levels of iridium.
Iridium. That rings a bell. Like the dinosaur extinction.
Exactly the same link. Iridium is rare on Earth's surface, but much more common in asteroids and comets. So, finding an iridium spike points to fallout from the Tunguska object. There might have been acid rain, too, from atmospheric reactions. Now, it's fair to say not all studies agree on all these peat results, but the overall picture is strong.
So putting it all together, the blast pattern, the standing trees, the lack of a crater, the microscopic spheres, the peat anomalies, it all points towards the airburst theory.
That's the leading hypothesis, yes, the most widely accepted explanation. A meteoroid or a comet entered the atmosphere, heated up, experienced immense pressure, and then detonated probably around 5 to 10 kilometers, maybe 3 to 6 miles above the ground.
It didn't need to hit the ground to cause all that devastation. The explosion itself, the shockwave, did the damage.
Precisely. The energy was released in the atmosphere.
And do we have an idea of the object itself? Like, how big was this thing?
Based on the energy released and comparing it with models and data from more recent events like the Chelyabinsk meteor in 2013.
Right, that one was much smaller, but still caused a lot of damage.
It did. So using that data, scientists estimate the Tunguska object was likely somewhere between 50 and 80 meters in diameter, maybe 160 to 260 feet across.
So roughly the size of, what, an office building? Or half a football field?
Something like that. And traveling incredibly fast. Estimates are around 27 kilometers per second. That's about Mach 80. 80 times the speed of sound.
Just, wow. Hard to even comprehend that speed and size hitting the atmosphere. It makes you wonder how often this kind of thing happens.
That's the million-dollar question for planetary defense, isn't it? Smaller airbursts like Chelyabinsk, maybe 500 kilotons, seem to happen every few decades. We see them.
But Tunguska-sized ones, 5, 10, 15 megatons.
Much rarer. Estimates range from maybe once every 300 years to once every 1,000 years. It's a wide range because our historical record is short. But interestingly, military satellites have been detecting smaller atmospheric explosions for decades.
Really?
Yeah, data that used to be classified is now helping scientists understand how often these things happen and how they break up. It's real-time data informing our understanding of this historical event.
Okay, so airburst is the main theory. But there's still debate about what exactly exploded, right? Asteroid or comet?
Absolutely. That's still a lively debate. The comet idea came first, back in 1930.
Because comets are mostly ice and dust.
Exactly. A fragile body that would vaporize completely high up, leaving no big fragments. That fits the lack of meteorites found. Plus, the glowing skies could maybe be explained by dust and ice from the comet's tail spreading through the upper atmosphere.
And the timing linked it to a meteor shower.
Right. The beta torids, which are associated with comet ink, so maybe it was a chunk of that comet, seemed plausible.
But then the asteroid idea gained ground later. Why?
Well, in 1983, Zdeněk Sekanina did some detailed modeling. He argued that a fragile comet entering at that shallow angle should have broken up much, much higher in the atmosphere.
So the fact it got so low before exploding suggested something tougher.
Exactly. Something denser, rockier, like a stony asteroid. That fit the energy release happening lower down. And later studies did find evidence of stony asteroid material in tree resin samples. Newer models, especially after Chelyabinsk, also lean towards a stony body disintegrating catastrophically. It could still produce the sky glows from all the vaporized material.
So the asteroid theory seems maybe stronger now.
It seems to have more support currently, yes, but then there's that even newer idea, the glancing impact.
Oh yeah, that sounds wild. Like it just skipped off the atmosphere.
Kind of. A 2020 study from Russian scientists proposed this. They modeled an iron asteroid, maybe bigger, up to 200 meters, coming in slower, around 11 kilometers per second. Their simulations suggested it could have grazed the upper atmosphere, caused the shockwave and heat we saw, and then just carried on back into space, into solar orbit.
Whoa. Is that widely accepted?
It's still a relatively new hypothesis, very much under debate. But it shows scientists are still thinking creatively about this event, trying to match all the observations. It's a persistent puzzle.
Okay, and speaking of persistent puzzles, Lake Checo. For a while, this seemed like it could be the smoking gun, right? An actual crater.
It definitely caused a stir. In 2007, an Italian team proposed that Lake Checo, which is about 8 kilometers from the hypocenter, might be an impact crater from a fragment, maybe a 10-meter chunk that survived the main airburst.
What was their evidence?
Several things. The lake has a very unusual conical shape, sort of funnel-like, unlike other lakes nearby. Magnetic surveys suggested there might be a dense object, maybe a rock, buried under the deepest point. And crucially, they analyzed sediment cores from the lake bottom. They found a distinct layer about a meter down. Below it, normal forest soil indicators. Above it, lake sediments full of aquatic pollen and stuff, dating consistently from around 1908 onwards.
That sounds pretty compelling, the timing, the shape.
It did seem compelling. The lake's long axis even points towards the explosion site.
So why isn't it case closed? What's the counter-argument?
Well, science keeps checking. Older studies, even back in the 60s, had already suggested the lake was much older based on the thickness of the silt they estimated maybe 5,000 years old. And then more recently, in 2017, Russian researchers did more detailed sediment analysis. They looked at radionuclide layers, traces left by nuclear bomb tests in the mid-20th century, and counted yearly layers called varves. Their results suggested the lake is at least 280 years old, maybe much older. The sedimentation rate was much slower than the Italian team thought.
So the 1908 layer wasn't the start of the lake, just a disturbance in an existing lake.
That's the implication. Plus, there's the physics problem. It's really hard for a stony fragment of that size, maybe 10 meters, to survive the atmospheric entry and airburst with enough speed left to blast out a deep conical crater like Checo. Most models suggest it would have lost too much speed or broken up completely.
Right. So Lake Checo, probably not the Tunguska crater after all. Still a mystery lake, perhaps.
Seems that way. It shows how science progresses, compelling evidence comes up, gets tested, new data emerges, and the picture changes.
It also shows how much people want a clear answer. Have there been other, maybe more fringe theories over the years?
Oh, absolutely, especially early on, before the airburst theory solidified. One geophysical theory, proposed by Wolfgang Krint, suggested it wasn't extraterrestrial at all, but a massive explosion of natural gas erupting from the Earth's crust.
Like a giant underground gas leak exploding.
Sort of. He imagined gas leaking out, rising, getting ignited somehow, maybe lightning, and then a plume of fire streaking back down to the source, causing the Big Bang.
Huh. Is there any evidence for that?
Not really, and it doesn't fit the evidence nearly as well as the airburst model, especially the extraterrestrial chemical signatures. It's largely dismissed by the scientific community now, but it shows the kind of thinking the mystery provoked.
Okay, so let's recap. Tunguska, largest recorded impact event in history, flattened a huge area of Siberia in 1908. Overwhelming evidence points to an airburst.
Right. An asteroid or possibly a comet, maybe 50, 80 meters across, exploding 5, 10 kilometers up. No crater needed for that level of devastation.
And studying this event isn't just historical curiosity, is it? It's crucial for us today.
Absolutely vital. Tunguska is our best real-world case study for understanding the potential hazards of larger asteroid and comet impacts. It directly informs planetary defense, how we might detect and potentially deflect future threats.
And those military satellites detecting smaller airbursts are constantly giving us more data points.
Exactly. Refining the models, helping us understand the frequency and physics of these events. Tunguska isn't just history, it's an ongoing lesson in cosmic risk assessment.
So here's a final thought to leave you with.
Oh.
Even now, over a century later, with satellites, supercomputers, all our modern science, the Tunguska story isn't completely closed. We're still refining the details, debating the object's exact nature, exploring oddities like Lake Checo. It really keeps you wondering, doesn't it? What else is out there, hurtling through space that we maybe haven't accounted for? What other cosmic surprises might be waiting to write the next chapter in Earth's long history?